we will be looking into a function called malloc. This does allocate memory during runtime. Okay, allocate memory during runtime. So far, what we have done, we have allocated memory using uh, statically. That means when we say int x, right, and say whatever 2, it means during compile time, we instructed the compiler to allocate a 4 bytes of data, right? This is 4 bytes of data, and we say assign it to 2. So this 4 bytes of data we allocated at compile time. This is called statically, right? And the other name for that is all called a stack space. We allocated memory from the stack space, right? And there is another concept, something called a heap space, right? And say during runtime, and you determine you need some memory. Let's say you want memory 8 bytes. Okay, say x equal to 8, and you want 8 bytes of data, right? That means we have in 8 bytes of data, how many ints you can have? 2 ints, right? Int 0, the first byte, int 1, second byte. So in this, if you want at runtime, you want to allocate this memory, malloc provides that. Okay, in this case, you say malloc. You could say x, it would take the value of x, or you can even say x malloc simply a hard-coded value 8 or something like that. Okay, usually we go for this approach, right? So that is memory allocation during runtime, and that is done using heaps. The memory is allocated from this heap space. If you want to do allocate memory during runtime, and when you call this function malloc, when it returns successfully, it returns the address of the first guy, address of this. Let's say the address is ff says 00, right? It's a hexadecimal number. For maybe we'll just keep it simple. Let's say the address is 8800. So it returns the address of this first address of this 8 bytes, right? Let's say 8800. Now what do you do with that? How do you want to traverse that memory? Do you want to traverse using char? Do you want to traverse the memory like a short? Do you want to do with int? How do you want to do this? Right? And generally it's up to your program. How do you want to do it? Do you want to traverse this array as a char, bunch of chars, right? 8 bytes are there, or do you want to just traverse by integer? Like I said, it depends upon your application. If you want to traverse this array, I just want to highlight that. If you want to traverse this array as int, right? So the way you do that is you declare I'll just erase this here. You declare a int pointer, int star pointer, right? And you cast that This is the way you do it. This is syntax, but as you go, you'll understand, you'll get used to it, right? So this line of code does, right, say 8. Okay, so let's dissect this line and see how we allocate memory at runtime. Okay, let's go take this one step further here. Malloc 8, it says allocate 8 bytes of data. So we got 8 bytes of data here, right? Very good. And it returns a first address, but that address is like a void pointer. We cannot void pointer. Okay, but we cannot do anything with the void pointer. We don't know yet. So we use a int point. We cast. This is called a casting. All right, this is called casting. This is called casting. We are casting that 8 bytes of data with int pointer. Okay, int pointer. This is what you do it. Okay, that is an int pointer. And then we declare a int pointer if you are not already declared, and the pointer is pointing to this dynamic memory. Okay, so let me go ahead, give me a second. Okay, let me erase this and do it again. Okay, say int pointer, that this is a pointer, and we could do pointer point to int casting. So this is called casting and malloc. Okay, 8 bytes of data. So if I want to explain this little bit, so this is called casting, a int pointer to a void pointer returned by malloc. Okay, allocate 8 bytes of data malloc returns, so this returns void pointer, okay, and so this is step 1, this step 2, and because you have an int pointer, it has to be assigned to a int pointer here. Okay, so now this is your lifeline. This is the pointer pointing to the memory you just allocated dynamically. Okay, let me open write store here. All right, now if I go back here, I will erase all these guys. So now you know how a memory is allocated. All right, now using this pointer, because we have 8, that means we have 2 integers, right? Each integer is 4 bytes, right? This is int first integer, this is the second integer, right? And pointer is pointing to that memory. All right, okay, now I can say pointer, I'm dereferencing. If I put say 1, right, That means one will get stored here, right? That's what dereference. We remember we did dereference. So this is a dereference, right? We did that. Now we have got taken care of, right? Now how do we access the second byte, right? So you have to advance the pointer ptr plus plus. When you advance the pointer now moves to this guy, to the second memory. And if you do a point equal to say 10, 10 will get stored here. Alright, so this is the first line of code, second line of code, and the third line of code. So just by, if you revisit this, right, we have int pointer, we have malloc allocating 8 bytes of data, it returns a void pointer, and we cast, this is called a casting, we talked about, right, casting. We cast that pointer using int pointer, and we are able to traverse this array, right? That's all about malloc.